Hello, everyone. My name is Julian, and I'll be the instructor for the course this semester, General Science Methods for grades 7 through 12. I'm looking forward to working with everyone this semester, and I'm hoping that the course will provide some insight into to teaching science and examining some best practices for helping students overcome some of their misconceptions in science. We'll start off by taking a look at the course syllabus, which can be found on Blackboard under course information. So you can access that on Blackboard. I'll highlight some key information that I think will be pertinent to you. The first thing, just to provide an overview of the course, the course is essentially designed to help teachers develop an understanding about the science concepts and skills that particularly pertain to the New York State secondary school science curriculum. We also want to help teachers develop teaching strategies to help students develop an appropriate understanding of science concepts. We also want to take a look at what science inquiry actually entails. It's a term that's often thrown around a lot and sometimes means something slightly different depending on who you're talking to. So we want to unpack this term science inquiry and see what it actually entails and how we can incorporate it effectively into teaching. And lastly, we want to be able to differentiate instruction for diverse learners, including students with disabilities and English language learners. Okay, so what I'm going to do next is I'm going to scroll down to the course requirements. Okay, and I'll talk a little bit about all of the assignments and when they're due and what they entail. Okay, so there are essentially 11 assignments. The first 8 assignments are discussion threads that are based on this book, Making Sense of Secondary Science. This is the required reading for the course. You can get a copy of that online on Amazon. And starting next week, we'll start off by taking a look at the first 3 chapters in the book, and you'll respond to the prompts on Blackboard under the discussion board. So each week, there'll be a discussion thread due for the next 8 weeks. Okay, and then assignment 9 is a PCK paper, and this information can be accessed once again on Blackboard under assignments. There's a description of the PCK paper, and I'll pull that up. Okay, so this assignment is due December 8th, and you're going to write a 3 to 5 page paper on some topic in science. And so PCK refers to the knowledge of teaching approaches that particularly fits the content and the student. Okay, so it's one thing to actually have the content knowledge, but it's another thing to know how to structure the learning and to structure the material in order to maximize student understanding. So in this paper, you're going to identify some topic in science in the New York State science curriculum. So for example, it can be something like density. And in the first section of your paper, you're going to first discuss what the scientific understanding, the actual scientific understanding of that concept is. So what is actually density? It's the mass per unit volume. It's a way for comparing different things. So that's what you're going to discuss in the first part of your paper. In the second part of your paper, you're going to take a look at student misconceptions. Okay, a lot of the misconceptions can be found in the book, which once again, in Making Sense of Secondary Science, there are a lot of misconceptions there. You could also look up some of the misconceptions online. I can point you to some resources to identify some misconceptions students have. You can interview students if you have access to students. You can interview students about what their ideas are. But the idea here is that you want to identify what some of these common misconceptions are. And then in the last part of your paper, you're going to describe an activity that will help students overcome that misconception so that you can move them towards the scientific understanding of that idea. Okay, so that paper, it's 3 to 5 pages. You're going to use standard 12-point font, double space. You'll reference in APA style. And once again, that's due December 8th. Now on Blackboard, under assignments, in addition to the description that you see here in front of you, there's also a rubric for this assignment, and there's also a science exemplar so that you can get a better understanding of just what the expectations are for that paper. Okay, so that's assignment 9. Now assignment 10, you're going to develop a unit plan on that same topic. So once again, if you wrote your paper on density, now you're going to create a unit plan on density, or it's more like a unit overview of a series of different activities, lessons, exercises that you would employ in order to teach the concept of density, for example. Okay, so there's a description once again on Blackboard under assignments, description of the actual assignment and what you need to include. On Blackboard, once again, there's also a rubric. There's also a unit plan template, and there's a unit plan exemplar so that you can take a look at. And if there's still any other questions that you have, feel free to email me, and I'll be discussing this in more detail throughout the course of the semester. And that assignment is due December 15th. Okay, let's go back to the syllabus. So that was assignment 10. And assignment 11 is essentially all of the videos that you're going to be watching on the different topics that we're going to be examining, and all of the virtual labs. Some people that had emailed me in terms of like what platforms we're going to be using. We're essentially going to be using Blackboard, Edpuzzle, and I'm going to provide some links on Blackboard that will take you to some other sites and resources where you'll be performing virtual labs. Okay, so let's go on to Blackboard so you can get a feel for how the course is structured. It's pretty much going to follow just a very similar format for each session or each week. Okay, so if you go under Blackboard, under course materials, you'll see a series of folders for each week. So for session 1, which starts the week of September 3rd, there's a folder here, and inside of the folder, it provides an agenda of everything that is going to be covered for that week. Okay, so you can see for session 1, week of September 3rd, there's introductions, which we're going through now, going through the course syllabus and the requirements and what the expectations are. In terms of the content for this week, there's a link to Edpuzzle, so you're gonna have to create a login. I emailed everyone a class code for Edpuzzle. I'll send that out again, but once again, you're essentially going to be utilizing a lot of videos off of this platform. Okay, so for this week, you're going to take a look at the next generation science standards, the science practices, in particular practice 1 and 2 of the next generation science standards. And there's also a video on lab safety that you'll be watching, and you'll be prompted to answer some questions, and everything is recorded on the Edpuzzle platform. Now, in terms of due dates, so the session 1 starts the week of September 3rd, and everything needs to be submitted by the end of that week, particularly by that Saturday at 11:59 p.m. So all of these items here need to be completed by September 8th. These 2 Edpuzzle videos on the science practices and on lab safety. And each week there'll be a similar format. So if you go on to course materials, just to give you a little bit more information. So for session 2, for the week of September 10th, okay, so once again, there's an agenda that lists all of the tasks that need to be completed. So for this week, you'll watch some Edpuzzle videos on science practices 3 and 4. There's a brain pop video on the scientific method that you're going to have to watch, and there's a link to that there with the username and the password. At the end of that brain pop video, there's some questions that you'll respond to, and you'll email the results to me. This week you'll start your first virtual investigation. So for that week, you guys are going to take a look at the scientific method. So you're going to do a virtual investigation where you have to incorporate the scientific method there, and you're going to collect some data, and you're going to be there's some documents where you'll collect the data and submit the actual report to me. So for example, the first virtual lab you're going to do is a virtual lab on the effect of light color. Okay, so if you click on this link here, it'll take you to this site over here where you're going to conduct a virtual investigation. And there's a handout where you're going to list the question that you're examining, what your variables are. I'm going to ask you to make a hypothesis. There's a description on this virtual lab here that will take you step by step, but you're essentially going to take a look at the effect of light color on plant growth. So in this particular lab, you're going to select what type of plant you want to do an investigation on. You know, you could select spinach. Down here, you can select what color light the plant will be exposed to. So the ones on this side will be exposed to red light. You can change the light color on the other side here, and then you would, turn on the light here, and then you get some growth there. And then you're going to make some measurements by using the ruler to measure your plant growth under these 2 types of light. And once again, there's a handout where you're going to record. There's a handout on Blackboard where you're going to record all of this information here. So you would record that, what question you're essentially taking a look at, which is essentially the effect of light color on plant growth. Prior to the investigation, you have to make a hypothesis, you have to make a prediction, and over here is where you're going to record the data of the plant growth under these light colors, so red, violet, so on and so forth. You're going to identify what your independent variable is, your dependent variable, what your constants are, and